When solving systems of equations algebraically, you could use either substitution or you could use elimination. I'm going to use substitution for this first example. I've got y equals x squared and y equals x plus 2. I'm going to substitute this y equals x squared into the y for the second equation, and I get x squared equals x plus 2. Now, since this is a quadratic equation, I am going to make it equal to 0. So I'm going to subtract x from both sides, and I get x squared minus x equals 2. Then I'm going to subtract 2 from both sides, and I get x squared minus x minus 2 equals 0. In order to solve this equation, now I can factor it. So I've got x minus 2 and x plus 1 equals 0. The solution for this side of my equation is x equals 2. And the other solution, the solution for this side of the equation, is x equals negative 1. Now I'm not quite finished. I need to go back to my equation y equals x squared, or I could go back to the equation y equals x plus 2. It doesn't really matter. And I'm going to substitute the 2 in and figure out what the corresponding y value is. So I get y equals 2 squared, which means y equals 4. So that means the solution for this side of my equation is 2 and 4. That's one place where my graphs will intersect if I solved it graphically. I can also put the negative 1 in. So I get y equals negative 1 squared, which means y equals positive 1, which means one of my solutions is negative 1, positive 1. So the solutions that will satisfy both of these equations at the same time are x is 2, y is 4, or x is negative 1, y is positive 1. Here's another example. Now this one I could also use substitution because I have a y equals equation. So I'm going to just substitute this directly into my second equation. So I've got x minus 2. And instead of y, I'm going to write negative 2x squared plus 10. And that's going to equal negative 15. Now to solve this, I want to get rid of my bracket. So I'm going to multiply the negative 2 into both parts of my brackets. I'm going to get positive 4x squared. And then 2 times 10 is going to give me negative 20 equals negative 15. It is quadratic, so I'm going to add 15 to both sides. And I get x plus 4x squared minus 5 equals 0. We don't like solving quadratics in this form. We prefer them in the order with x squared first. So I'm going to rewrite this as 4x squared plus x minus 5 equals 0. Now I need to factor this. So I'm looking for two things that are going to multiply to give me 20, because 4 times 5 is 20, and add to positive 1. So my numbers are going to be negative 4, so I've got negative 4x, and positive 5, so I've got positive 5x. So I've taken this middle 1x here and I've split it into negative 4 and positive 5. Now I'm going to factor both sides of my equation. So out of the first two I can take out a 4x, and I'm going to be left with x minus 1. Coming out of the second one I'm going to be left with a 5, which will leave me with x minus 1, which means my factors are going to be 4x plus 5 and x minus 1. Since to get a solution, both of these factors are going to have to be equal to 0. To make this one equal to 0, x is going to have to be negative 5 over 4. To make this one equal to 0, x is going to have to be 1. I'm going to look back at my original equations and decide what the simplest one is. I'm going to use the first one because it's already in a y equals form. So y equals negative 2x squared plus 10. So negative 2x squared plus 10. I'm going to put my negative 5/4 in first. So I've got negative 5/4 squared plus 10, which leaves me with negative 2 over 25/16 plus 10, which leaves me with, if I divide both of these by 2, I'm going to get negative 25 over 8 plus 10. If I change 10 to something over 8, I'm going to get 80 over 8, which is going to leave me with positive 55 over 8. So my solution to this one is negative 5 over 4 and 55 over 8. So that's my first solution. And I could check that by substituting it back in. My second solution, I'm going to take the same equation and substitute in a 1, which is going to be much easier. So I get y equals negative 2 plus 10, which means y equals 8, which means my solution is going to be positive 1, positive 8. So now I have two different solutions for my system of equations. One possible solution is x is negative 5 over 4, and y is 55 over 8. My second solution is going to be y equals 1, x equals 1, and y equals 8. Another way I could do this is by elimination. So here's a question where I've got the x squareds lined up, the x's lined up, the numbers lined up, and the y's lined up. If I want to get rid of the y's, I could subtract both equations. So y minus y is going to give me 0. 2x squared minus negative x squared is going to give me 3x squared. Negative 7 minus negative 6 is going to give me negative 13x. And 3 minus negative 7 is going to give me positive 10. So now I could factor this, of course. Multiplying to give me 30 and adding to give me negative 13 is going to be negative 3x and negative 10x. Here I could factor out a 3x, and that's going to leave me with x minus 1. Here I could factor out a negative 10, and that's going to leave me with x minus 1. So my factors are 3x minus 10 and x minus 1, which means this x is going to be 10 over 3, and this x is going to be 1. Now we need to take our two values that we solve for x and figure out what the corresponding y value is. So I'm going to use the equation y equals 2x squared minus 7x plus 3 to figure these out. I'm going to start with the fraction because it's the more difficult one. So I've got 2 times 10 over 3 squared minus 7 times 10 over 3 plus 3. When I square this out, I get 2 times 100 over 9 minus 70 over 3 plus 3, which gives me 200 over 9 minus 70 over 3 plus 3, which equals 17 over 9. So my solution for this one is 10 over 3 and 17 over 9. For my 1, I substitute in the 1. This one's going to be a little bit easier. 1 squared minus 7 times 1 plus 3. I get 2 minus 7 plus 3, which is negative 5 plus 3, which is negative 2. So my second solution is going to be 1, negative 2. So it doesn't really matter whether you use substitution or elimination to solve these. You can use whatever's easier. But in this case, again, we end up with two solutions.